Now I'll execute a simple bivariate regression. To do so, I've already checked the assumptions for a Pearson's R, which are the same assumptions for a simple regression or a bivariate regression. So to execute a bivariate regression, I'm just going to go back up to the Analyze in the menu bar, click it. When the menu appears, I go down to the middle of the menu, hover over regression, and a pop-out menu to the right appears, and I choose linear. A new dialog box will pop up, and I want to put my dependent variable, which is behavioral precautions, into that top box labeled dependent. And I'm going to put my independent variable in this box here. How concerned about crime in general are you? I'm also going to go to the statistics button. And I'm going to add part and partial correlations, but notice that model fit and estimates should be default checked. I'll click continue, and then I'll click OK on this dialog box. SPSS generates the output, and with the regression, notice the top box just describes the variables that are entered into the regression. The dependent variable it names here, the independent variable it names up in this box. I scroll down, it gives me a model summary. It tells me the overall R square. Here the overall R square is the collection of independent variables. This is important because in a simple bivariate regression there's only one independent variable. However, in a multivariate regression there may be multiple independent and control variables. So this R square describes how much variance the set of independent or control variables explains in the dependent variable. But we only have one variable here, so that one variable explains 8.4%. Next is another box that describes the model. So this is referring to the collection of independent and control variables and how well they explain the dependent variable. So overall, the collection of independent and control variables significantly predicts the dependent variable. We see that by the probability value here less than our alpha level of 0.05. I scroll down even further, and I'm going to scroll to the right a bit. So this describes the individual coefficients. So here, I see how concerned are you about crime in general. This is my independent variable, and this is the slope, right? The unstandardized coefficient is 0.457, and this is the standardized coefficient, 0.291. So the unstandardized coefficient of 0.457 indicates that for each unit increase in how concerned are you about crime in general, it moves the dependent variable positively or increases it by 0.457 units. The standardized coefficient of 0.291 indicates that for every one standard deviation increase in the independent variable in concern about crime, it increases, because it's positive, the dependent variable by 0.291 standard deviations. We know it's significant because the probability value is less than 0.05. Also, we see the original correlation. This is referred to as a zero order correlation for the bivariate relationship. It's the same, 0.291. It's positive. Notice here that the zero order correlation corresponds to the standardized coefficient beta. It will not always be the case. It does here though, especially in a multivariate situation. So if we were going to try to predict how many behavioral precautions someone takes using the formula y equal a plus bx, here's our constant, 6.667 plus 0.457 times x. And so if we wanted to know how many precautions somebody was going to take, we just have to substitute the value of the level of concern. It ranges from 0 to 10. So let's say we want to examine how many behavioral precautions someone takes who has a level of 10. So 6.667 plus plus 0.457 times 10. That results in 6.667 plus 4.57, which is roughly 11.1, 11.2. So someone who has a concern on the level of 10 will take roughly 11 behavioral precautions taken as a result of concern about crime.